Okay, find the derivative of the following function by first principles. Use the derivative to find the slope of the tangent at 4, 8, and then write the equation of this tangent. So, they give us a function, and we're finding, in the previous unit we were calling this the slope of the tangent line. Now we're using the new term derivative, but it's the same procedure for now. The derivative is the limit as h goes to 0 of f of x plus h minus f of x all over h. F of x is given to us. F of x plus h we get to crunch out, which I will do now. It's 2x squared minus 6x, which is 2. When you FOIL x plus h, you get x squared plus 2xh plus h squared minus 6x plus h. That's 2x squared plus 4xh plus 2h squared minus 6x minus 6h. Okay, any like terms in that? It looks like not. So all of that is f of x plus h. Let me declutter the page a little bit. Okay, so our derivative formula is limit as h goes to 0, f of x plus h, so all this stuff, 2x squared plus 4xh plus 2h squared minus 6x minus 6h minus f of x, which is 2x squared minus 6x, we are told, all over h. Now we try to clean it up, which usually goes well. I see 2x squared minus 2x squared. Here's a minus 6x and minus 6x. Those cancel. So we end up with 4xh plus 2h squared minus 6x all over h. If we divide the top and bottom by h, we get 4x plus 2h minus 6. Now, we're in the limit as h goes to 0, so this middle term will vanish, and that means our derivative is 4x minus 6. They're saying anywhere you go on this parabola, the slope is given by 4 times the x position where you are, minus 6. And that'll work every time, they claim. If x is 4, then the slope at 4 would be 4 times x minus 6. 4 times 4 is 16, minus 6 is 10. So at that point, they're talking about the slope is 10. I didn't need the y-coordinate because this slope formula doesn't say anything about y. It says, just give me the x, that'll be enough. So that the derivative is 10. You can write that either f prime of x equals 10, which is a popular notation, and you'll see it a lot. The notation I like better is Leibniz notation, which looks like dy dx equals 10. That takes a little longer to write, I know, but it's more helpful later, and it's more meaningful now even, because this reminds you it's a slope. Dy dx means the change in y over the change in x, meaning rise over run. And later, there are some places where this way of writing a derivative will make some things obvious that are not obvious in the prime notation. So you're going to, and I accept that you're going to use this a lot, but please remember your Leibniz notation. It is your friend, and it will help you a bunch if you get familiar with it later on.